Hello learners, in this session we shall learn about polynomials. Polynomials comes from poly meaning many and nomial in this case meaning term. So it says many terms. A polynomial can have constants, variables and exponents but never division by a variable. For example, in A, an example of polynomial in two variables, whereas B is not a polynomial because the variable has an integral power. Let's talk about the types of polynomials. Polynomial can be classified by number of non-zero term. If the number of non-zero term is 0, it is called a zero polynomial and example is 0 itself. When their number of terms are 1, so it is called a monomial and example would be x square. Similarly, if the number of non-zero terms are 2, it is named as binomial and the example is x square plus 1. And lastly, if the number of zero terms are 3, so it is named as trinomial and the example would be x cube plus 2x plus 1. The degree of a polynomial is the highest degree of its term when the polynomial is expressed as a linear combination of monomials. The degree of a term is the sum of the exponents of the variables that appear in it. For example, in the polynomial 5x to the power 12 minus 2x to the power 6 plus x to the power 5 minus 198x plus 1, the degree of this polynomial is 12. In the second polynomial x to the power 4 minus x cube plus x square minus x plus 1, the degree is 4 and so on. If you observe the last polynomial minus 8, the degree here would be 0. Evaluating the polynomial. Evaluation means simplifying an expression down to a single numerical value. For example, to evaluate x to the power 4 plus 3x cube minus x square plus 6 for x is equal to minus 3, we'll substitute the value of x in each term as minus 3 and we'll get minus 3 as a solution. Talking about zeros or the roots of a polynomial, it is a solution to the polynomial equation px is equal to 0. It is that value of x that makes the polynomial equal to 0. For example, the number 2 is the root of the polynomial x cube plus 2x square minus 7x minus 2 because when we substitute p2 or that is x as 2 in each term, we get the answer as 0. So 2 is the root of this particular polynomial. Lastly, we come to the operations of polynomials. Polynomials like arithmetic numbers can be added, subtracted, multiplied and divided. Let us learn each operation one by one. To add or subtract, arrange the given polynomials in standard form. Now, standard form of a polynomial just means that the term with highest degree is written first and rest of the terms are written in decreasing order of their power. Arranging the like terms in linear forms or columns and add or subtract as required. For example, to add 5a square plus 3a minus 9 and 6a square minus 5a minus 7, we arrange all the like terms together, that is 5a square plus 6a square in one bracket, 3a minus 5a in another bracket and lastly minus 9 and minus 7 in last bracket. Now solving the integral values of each like terms, we get 11a square minus 2a minus 16. So this would be the solution by adding the two polynomials. Similarly, we can subtract two polynomials as shown here. 6x square plus 4x minus 9 minus 4x square minus 7x plus 3 in bracket will give us 2x square plus 11x minus 12. Next we come to multiplication of polynomials. To multiply monomial by monomial such as 5x square and minus 2x cube, multiply the numerical coefficient and the variables using the law of exponents. That is 5x square multiplied by minus 2x cube will give us minus 10x to the power 5. To multiply a polynomial with another polynomial, we follow the distributive property. For example, to multiply x plus 3 and x plus 2, we distribute x with x plus 3 and 2 with x plus 3 again. So that will give us x square plus 5x plus 6. The division of polynomials can be learnt as given in the example. 4a cube b plus 2ab to the power 4 minus 8a cube b5 divided by 4a square b. So when we divide a polynomial by a monomial, we separate the fractions, that is 4a cube b upon 4a square b plus 2ab to the power 4 upon 4a square b and minus 8a cube b5 upon 4a square b. In the second step, divide each monomial and we'll get the answer as a plus b cube upon 2a minus 2a square b to the power 4. While dividing a polynomial by another polynomial, we eliminate the first term by multiplying the divisor by a suitable term and keep doing so till we get a remainder with degree less than the divisor. For example, here divisor is 2x minus 3 and the dividend is 2x to the power 4 minus 9x cube plus 21x square minus 26x plus 12. So first we divide the first term, that is 2x to the power 4, and we get the quotient as x cube. Similarly, we carry on this method till we get the remainder with the degree which is less than the divisor or a 0.